Hey friends, happy Holi, and I'm Rajnish Thakur, and I'm going to teach you inspiration. First, before introducing myself, I will start the day with a song. Living with this fluid, sweep away my pain, bring the healing to my heart, help me live once again. Cares and worries let me down, fears of failures fills my day. When I am lost all alone, help me Lord to find your way. People coming to my life with the laughter and the song, never let me turn them down. Show me gently how to share. Children's coming to my life with the laughter and the song. When will I become like them? Teach me Lord to sing along. Living what is flowing, sweep away my pain, bring the healing to my heart, help me love once again. So hey friends, here I am for teaching you integration. I'm Rajnish Thakur. I'm a 10th going student, and I have completed my integration when I was only of class 7. For 2 years I was researching on integration, plus 8 and plus 9, and because of my friends urged me to do, I made up my mind to make a video on YouTube and make a page on social media apps on integration. As I made many videos and thought of uploading. It was on music. I will be opening shortly my music channel also. Please hear that also. So here I've been researching on integration, as you say, to make it a more approachable factor for the kids below class 7, class 5 or class 6 you can say. So let's start our day with a great smile and have a nice day. Our question is on integration. First, my friends, I want to ask you a question. After you hear the question, I have a request. You please stop the video, write in comment the answer as answer 1 of this question. Please, after hearing the question, you please stop the video and write the answer what you think as a definition, and then again retreat to the video. Let's start. My question is, what is addition? What is addition? You have 15 seconds time. Please stop the video, write the answer in the comment that what do you think by definition of addition, and I'll be doing the definition after 15 seconds. And here it goes. Please give the answer in the comment box, and if you have completed, my definition goes here. What is addition? What is addition? Addition is the algebraical Addition is the algebraical joining of any two points in the universe. I want to join any two or more things in the universe. The algebraical addition, the algebraical joining of two or more points of the universe is known as addition. One more time. The addition is the algebraical joining of two or more points or things of the universe. So we can say that the adding of infinitely small things, infinitely large number of times gives us a definite value. The adding of infinitesimally small things, infinitesimally large number of times gives us a definite value. So here we can see what is to be explained. This basic concept in triple calculus, and one of the limits, if you know. 1. A simple digit 1 can be written as half plus half. The parts are going smaller and the number of times is getting larger. Here we have only one part and it's larger than half. And we can even write it as 1 by 3 plus 1 by 3 plus 1 by 3. 1 by 3 plus 1 by 3 plus 1 by 3. The parts are going even more smaller. The parts are even going more smaller and the number of times is more larger. And we can even write it as 1 by 1000 plus 1000 times. This quantity, this part is sufficiently small and the number of times is sufficiently large, and when its part goes to be 1 by infinity or 1 by 1 by very very large, 10 to 50 you can say, adding 10 to the power 50 times gives us a feeling that it's a large quantity of adding. But actually you can think that we're just differentiating 1 into smaller parts. So we can understand adding of very small things a very large number of times gives us a large value or small value or definite value. Please stop the video and write it. Gives us a definite value, very large value or a very small value. Actually it depends upon the parts, smaller parts or the number of times we add it. So here we can say it gives a definite value. Here where the calculus comes, we do 1 by n plus ... n times, where n tends to infinity. We in concept of calculus do n tends to infinity, 1 by n into n tends. We can define one in this way also. But what is 1 by n and n tends to infinity? What is n tends to infinity? What is infinity actually? This is term used for infinite simile. That this term infinite simile or infinite means a great extent, which we cannot even think by our mind. For example, a simple number 2, which is a very small amount to us, is infinitesimally large in front of 10 to the power minus 50. If we can see 2 in front of 10 to the power minus 52 is infinitesimally large. We can call 2 even an infinity if our compound digit is now 10 to the power minus 50. In front of 10 to the power minus 52 is also large. In front, even a simple digit 50 is even large. Infinitesimally large and 10 to the power minus 30. And even a simple digit 1 is large, infinitesimally large than a very small value 10 to the power minus 10,000. And even a great digit 10 to the power minus 10 to the power plus 10,000 is large in front of 100 also. And you can see that 10 to the power minus 10,000, sorry, plus 10,000, excuse me for the mistake, 10 to the plus 10,000 is much more than 100. And it's infinity in front of 100 even. Then what? We can think by infinity. Infinity is a large quantity. Infinity is a large quantity. It doesn't mean 1 by 0 or something like that. It's a large quantity, even it's out of our thought. It's as much as large, we cannot think. If you're not getting what's infinity, even now, I would have to be specific. For example, today is your birthday, and you will say 12 years old. Will you tomorrow say 12 years one day, your age, if anyone asks you? Will you say tomorrow your age is 12 years one day, or 12 years? For example, if today is your birthday, and you are becoming 12 years old, but tomorrow your age becomes 12 years one day. But you will always say your age 12 years. Tomorrow, day after tomorrow, and after that. 12 years only you will say. But you will not say 12 years one day, 12 years 2 days, 12 years 3 days. You will not say. What is the reason of that? 1 day, 2 days, and 3 days are infinitesimally small in front of 12 years. 12 large years is sufficiently large in front of a single 2 or 3 days. So we cancel a day. So one day we cancel it. Why will we say one day? It's sufficiently small in front of 12 years. Hence, we can now, I think we're getting a bit the concept of infinity. So that our next concept is what is. So our next concept is what is summation, what is integration, what is the difference between summation and what is the difference between summation and integration, and how can you convert summation to integration. And that's what we are going to see here. Summation. Summation is nothing but addition. The summation is nothing but addition. The summation is denoted by sigma. We can see that summation is denoted by a Greek word sigma, means capital sigma. Here we can take, we should take capital sigma. Here we give the initial value, means the lower limit, x equal to 1 and 2x equal to 10, 15, whatever we say. We can do summation of discrete values. Then what is integration? The integration is a continuous summation of things. Continuous summation. So as I was saying, the adding of small values a large number of times gives us a definite value. So there are three types of series. We know there are three types of series. Number one, converging. Number two, diverging. And number three, in which number three is a type of series in which all the it's you can say constant series. Number three, you can say constant series. A converging series can be infinite. We're talking about infinite series. Here we are talking about infinite series. We are adding parts to infinite number of times. Here we are talking about infinite series. Can a diverging series be an infinite series? No. A diverging series can never be an infinite series. And if it be, it will become the summation will give a large infinite number. The infinite summation of a diverging series gives an infinite number. And about converging series? The converging series, when added up to infinitely, gives a definite value. And if the constant series, the parts are very, very small. Parts are 10 to 0, added infinitely, gives a definite number. And this is called integration. And number three is called integration. It's nothing different from integration. So here we can see what's integration. It's infinitely small things added up infinitely large number of times to give up a definite value. Therefore, we can see that integration is adding up of infinitely small things are infinitely large number of times. Therefore, what is the difference between the summation and the integration? What is the difference between the summation and the integration? Difference between the summation and the integration. Summation is the adding of discrete points. Integration is the adding of continuous curve. This is the most important part to learn. Summation is the addition of discrete points. Integration is the addition of a continuous curve. Summation, we can say means we are adding 1 and 2 to form up 3 is also summation, and we are adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. It's also summation. Okay, here means the number of terms that we add may or may not be infinite. The number of terms we add may or may not be infinite. The number of terms we add may or may not be infinite. Even 1 plus 1 is also summation to form 2. And even 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 is also a summation forming 55 is also a summation. And even means adding from half to 1 by means adding 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 plus 1 by 64 dot 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 1 by infinity is also summation. We are adding finite things in a summation also. It is a converging series. But in integration, the number of terms is infinity. Number of terms added. Number of terms added. Number of terms added is infinity. In an integration, the number of terms added. Not means that it's not actually a number of terms. It doesn't add terms, it adds points. In integration, it doesn't add terms, we add points. And the number of points we add is infinity. We add curves. We find the area of curves. We don't find the area of points. We don't find the area under some points. We find area in the whole curve. From x equal to say 1 to x equal to 10, we find the whole area of the curve. We don't find the area under a simple single point as x equal to 1, find the area under x equal to 1. No one says like that. But actually, the area under a single point is 0. As by you can say Euclid's definition, our point is no length, no breadth, no height. And how can we make a summation to an integration? First, we should learn what are the uses of integration. What are the uses of integration? Integration is used to find the area of a curve. And the most important thing we have to learn in integration is just nothing but adding, means finding the area of a curve. Area enclosed by a curve. Integration is nothing but the area enclosed by a curve. What is the area enclosed by a curve? Is this area under any curve? Is the area with the x-axis? It may be the area with the y-axis. For example, if we integrate with something y dx, it is the area under x-axis. For example, there is some function like. For example, say there is some function like this way, and we are doing integration of x dy. Then we will take the integration with respect to y-axis. And if we say y dx, we will take the integration with respect to x-axis. The differential term forms the axis. With the dx, if we take dx, we will find the area with respect to the x-axis, and if we take dy, we will find the area with respect to the y-axis. Got my point? If anyone is not getting, write in the comment. And my phone number is given, actually my WhatsApp number is given at the last of the video. You can just take it and call me or even message me if you don't understand it. Then the next thing we are going to learn is how to convert integration. The next thing we are going to learn is how to convert integration to a summation or a summation to integration. Both are possible. But first let's see how to convert a summation to an integration. How to convert a summation to an integration. In summation, we add up small things. Not small things, means we add up discrete things. And integration, we add up small things. Summation, we are adding up points like this way. And in integration, we are adding up points like this way. These are the points. For integration, we add the whole points. All the points between certain limit. From here to here, we add up all the points. And in you say summation, we add up only say natural numbers or something like that. With some discrete points we add. So if the gap between the 2 points we are adding can be made tends to 0. If the gap between 2 points we are adding be more closer, the 2 points we are adding should be more and more closer, such a closer that the gap between them should be 0, not 0, tends to 0. Then we can convert summation to integration. Maybe you are not guessing it. For example, there will be any curve, any curve, you know. Take it y equal to fx, and y-axis, x-axis, and you know. We are adding it from here to here. X equal to x0 to x equal to xn. We are adding it. We are dividing it in n small parts. And what is n? Limit n tends to infinity. This n is a sufficiently large number, so we are dividing this to parts. This much of area we are dividing into infinitely small amount of quantities. We are dividing into small amount of quantities, and this each part, each length, each point, difference between each point is 8, and this 8 tends to 0, as this is an infinitely large quantity. And here it's any x we are taking it. That is RH. Any general x is a R, and R is the variable. We are getting it. If you are not getting it, please tell it. We are taking the area of a single curve as h tends to 0. As h tends to 0, we can tell it a rectangle. We can tell it as a rectangle. We can consider it as a rectangle. Who has a rectangle, we can consider it. And here, this much is a this point is RH. Therefore, here this length means if you input x, the function will give fx. If you input RH, the function will give FRH. It's as simple as it is. The function will give FRH. Therefore, this length is FRH. This length is FRH. This length is FRH. This length is FRH, and this length is h, as I said to you. Therefore, FRH dot h summation from r equal to 0 to n gives us the value of the integration fx dot dx from integration from xi. This is very similar to this. These two are very, very similar. And we've converted the integration to summation and the summation to integration and vice versa. So, next point we go. We'll take some common curves and see how the integration comes. We'll say take some common curves as you will be able to see. Some common curves we'll take. Some curves we'll take. First curve we'll take y equal to x. Integration will see y dot dx equal to this. We'll see that what will be equal to. Therefore, it will be a straight line passing through origin. And if the curve is y equal to fx, where fx equals x. Therefore, similarly, we are dividing it into n small parts. We are integrating from 0 to x final we are integrating. And therefore, x final by n is h. We are dividing this part into n infinitely smaller parts. And n infinitely smaller parts into infinitely large number of times. Limit n till infinity. N is a large number and h is in an infinitely small part. H tends to 0. H tends to 0. H tends to 0. H is an infinitely small number and n is an infinitely large quantity. N is an infinitely large quantity and h is an infinitely smaller number. So we can see that here this point is RH. R is means I will take limit for r equals 0 to n. Here is RH, therefore this length is also RH. F of RH equal to RH as fx equal to x. This means this length is RH. Means actually this length is RH. Therefore, as it is 45-degree angle, therefore tan theta equal to RH by RH equal to 1. Therefore, it's also RH. If not getting it, you should have. If you are not getting it, you should have taken the knowledge of trigonometry a bit. I'll be uploading videos on trigonometry also. Coordinate geometry and everything I'll be uploading on YouTube. And first like this, we should have, if this is a 45-degree angle, this is RH and this is also RH. Therefore, this length is RH and this much length, we will consider a rectangle. And this length is h as you know that. Therefore, RH dot h sigma r equal to 0 to n. Here it's the summation s we are taking. H squared is a constant. H squared is a constant. Sigma r equal to 0 to n r. What is sigma r? What is sigma r? What is sigma r? It's the summation of 0 to n. It's as simple as it is. N into n plus 1 by 2 into h squared. Got it? And n is very, very large and n tends to infinity as I said you. N tends to infinity. Therefore, n plus 1 gives us n. For example, if I give you 10,000 rupees and add a single rupee on it, you will say what is your money. If I tell you what is your balance, you will say 10,000 rupees and not say 10,001 rupees. Therefore, you can ignore this one. Therefore, it becomes n squared into h squared. N squared into h squared by 2. And here you can see that xf equal to nh. Here we can see that xf equal to nh. And n squared h squared can be written as xf squared. and this is very equal to the integration which is done by x into dx 0 to x7. This also gives x to the square minus 0 square by 2. Therefore, it's a very similar result. And next function we will be taking y equal to x square. Next question we are going to take it as y equal to x square. Y equal to x square. Y equal to x square. It's also a similar process. We are integrating it from, you say, xi to xf and dividing it into say n smaller parts, each of length h, and this is a rh, and this part is rh, and this length is frh, and we can see that fx equal to x square. Therefore frh equal to fr square h square. As fx equal to x square, fx equal to x square. Therefore frh equal to r square h square. Very simple. Therefore this length is r square h square, and this length, this part is h. Therefore the summation will be r in r square is h cube, r equal to 0 to n. And one more thing we have to forgot, xf minus xi equal to n, equal to h, by n equal to h, as this part only we have divided into n's infinitely small parts. N is an infinitely large number, therefore this part, each part is very infinitely small parts. Therefore the integration, this summation comes to be r into r plus 1 into 2r plus 1 by 6 into h cube. Oh, sorry, it's n, and here also n, and here also n. Therefore n plus 1 is n plus 1, as I said you, 10,000 plus 1 will not say it 10,001, we'll say 10,000 only. Therefore n into n. We are adding 2n plus 1, and it's nothing but 2n by 6. Therefore it will into h cube. Therefore it will be n cube h cube by 6 by 6. Sorry, it's n cube h cube by 3. It's n cube h cube by 3. It is n cube h cube. This is the summation. The summation is n cube h cube by 3. And therefore from here you can get xf cube minus xi cube by 3. The summation is very equal to the summation, but you do as simple. The simple summation will also become xf cube minus xi cube by 3. Integration of x squared dx, you get this only. And here we can see the solution. The summation, both the solutions and the integration are very similar. Bye friends. Be with me in the next video. If you like this video, share and like, and you can subscribe my channel. Don't forget to do it. Bye.